Good afternoon, students. Now we will start chapter 3, motion in plane. In last lecture, we already seen what is the meaning of projectile motion. Now, see, any object thrown in the air being of some velocity is called as projectile, and this motion is called as projectile motion. Now, in last lecture, we already said what is the projectile motion, what is the time of flight, equation of time of flight, and maximum horizontal maximum range, which is depends on the magnitude and direction of initial velocity of projectile as well as the value of acceleration due to gravity at that place. Now, in this lecture, now we will see maximum height. See, the maximum height h reached by projectile is the distance traveled along the vertical y direction in time t0. This can be calculated by using this equation. This one is the 3.41 equation is sy is equal to u sin theta into t minus half gt square. Now substitute the value of t is nothing but t0. Now we get this equation h is equal to u sin theta into t0 minus half g t0 square. Because of in y direction the time is nothing but 0. Therefore, we solving this equation, we get u sin theta is equal to substitute the value of t, that is time of flight. We are already seen in last lecture. T0 is nothing but sin theta upon g minus half g. Substitute value of again T0 is u sin theta upon g bracket square. Then we get the equation here u square sin square theta upon 2g is equal to, solving this equation we get u square sin square theta upon 2g is equal to u square y upon 2g. This equation is the maximum height reached by the projectile is distance travel along the vertical y direction in time t0. Now, next point is that equation of motion of a projectile. See, we can derive the equation of motion of projectile, which is the relation between the displacement of the projectile along the vertical and horizontal direction. Along the vertical, that is y direction. Along the horizontal direction, that is the x direction. This can be obtained by eliminating between the equations giving the displacement. Now, these two equations, in last lecture, we already seen these two equations, 3.40, 3.41, where 3.40 equation is Sx is equal to u cos theta into t. And 341 is nothing but Sy u sin theta into t minus half gt square. Now, substituting this equation in 3.40 and 3.41, we get substitute. As the particle starts from x is equal to 0, we can write Sx. S is nothing but displacement along x direction is x, and Sy along y direction, vertical direction is y. Sx, now equation 3.40. What is the equation 3.40? Is nothing but Sx u cos theta into t. Therefore, t is equal to, solving this equation, t is equal to Sx upon u cos theta. And therefore, Sx is nothing but substituting x. Therefore, x upon u cos theta. Okay. Now, next one. Now, the equation 3.41. Okay. What is the 3.41? Y is nothing but u sin theta t minus half gt square. Now substitute t value x upon u cos theta in above equation. We get u sin theta as it is. T value substitute करूया. X upon u cos theta minus half g as it is. T square is nothing but x square upon u square cos square theta. Bracket square घेतला तरी चालेल. The equation becomes, now you get cancelled. Sin theta upon cos theta is nothing but tan theta into x minus half as it is g u square cos square theta into x square. And this is the equation of trajectory of projectile. Here u and theta are the constant for the given projectile motion. And this equation can be written in that form: y is equal to x plus bx square. That is the equation of parabola. That is, the trajectory of the projectile is a like parabola, where a is nothing but tan theta into x and b is nothing but half g u square cos square theta. Now I can again explain this for this point. Equation of motion of projectile. We can derive the equation of motion of projectile, which is the relation between displacement of the projectile along the vertical and horizontal direction. This can be obtained by eliminating between the equations giving the displacements. That is, first of all, SS displacement x घेतला, SY displacement y घेतला. Substituting this value, the equation becomes y is equal to tan theta into x minus half j u square cos square theta into x square. This is the equation of the trajectory of projectile, and this can be written here in the form of equation of parabola, that is y is equal to x plus bx square, where a is nothing but tan theta into x, tan theta only, and b is nothing but half g u square cos square theta. Next one, uniform circular motion. Where this one is called as uniform circular motion, where axis, this one is the centripetal force, velocity, and omega is nothing but angular velocity. Now we can see, for first of all, what is the uniform circular motion? An object moving with a constant speed along a circular path is said to be in uniform circular motion. That is called as UCM. Again, I can explain. An object moving with constant speed, constant velocity along a circular path is said to be in a uniform circular motion. Such motion is only possible if its velocity is always tangential to a circular path without any change in its magnitude. When called as uniform circular motion, only possible only if its velocity is always tangential. See here, the velocity is always a tangential to a circular path without change in its magnitude. That is a constant velocity, constant speed along the circular path is called as the uniform circular motion. Now, explanation of uniform circular motion. Now see in this picture, centripetal acceleration, and that force is called as the centripetal force. Centripetal force and centrifugal acceleration is nothing but that force is called as the centrifugal force. First of all, see, to change the direction of velocity, acceleration is must. Because of to change the direction of velocity, acceleration is must. However, if the acceleration or its component is in line with the velocity along to the opposite to the velocity, it will always change the speed, that is magnitude of velocity, in which case it will not continue its uniform circular motion. The magnitude change झालं velocity, that the uniform circular motion होत नाही. When the velocity of its magnitude is constant, then that motion is called as uniform circular motion. In order to achieve both this requirement, the acceleration must. And there are two types of acceleration: perpendicular to the tangential velocity, and second, constant magnitude, and third one, always directed towards the center of the circular trajectory. And such an acceleration is called as centripetal acceleration, and that force causing this acceleration is called as centripetal force. That is, centripetal force is nothing but the force which is directed towards the center of the circle, and opposite to that of centripetal force is called as the centrifugal force, that is away from the center of the circle. See, Again, I will explain. Always directed towards the center of the circular trajectory, such an acceleration is called as centripetal acceleration, and force causing this acceleration is called as centripetal force. And opposite to that of centripetal force is centrifugal force, which is away from the center of the circle. See, centripetal acceleration, the acceleration of an object in circular motion acting towards the center of the circle. Towards to a center of the circle as the centripetal force or centripetal acceleration. The force which acts as an object towards the center of the circle to produce the centripetal acceleration, and centrifugal force, which is equal and opposite reaction to the centripetal force, that is the force which acts on an object away from the center of the circle to produce the centrifugal acceleration. That force is called as the centrifugal force. Thus, in order to realize there are two requirements, tangential velocity and second one is the centripetal force of a suitable constant magnitude. And an example of this centripetal force, that is the motion of the moon going around the earth in a nearly circular orbit as a result of constant gravitational attraction of a fixed magnitude field towards the earth. This is an example of the centripetal force. Now, next one, there is some terms where the period, radius, vector, and angular speeds definition. First of all, C period m moving with a uniform speed v along a circle of radius r. Then let T, capital T with the time period of revolution of the object. Then the time taken by the object to complete one revolution or to travel the distance of 2 pi r. That is the period of the object. What is the definition of period of the object? The time taken by the object to complete one revolution or to travel a distance of 2 pi r. Thus, capital T is equal to 2 pi r upon v. Speed v is equal to distance upon time. Therefore, 2 pi r upon t. During the circular motion of the point object, the position vector of the object from the center of circle is the radius vector r. Its magnitude is the radius r and it is directed away from the center of the particle. And that is away from the center of the circle as the particle performs uniform circular motion, and this radius vector describes equal angles in equal interval of time. And this is called as the radius vector. At this stage, we can define a new quantity called as angular speed, that is omega, which gives the angle described by the radius vector per unit time. What is the meaning of angular speed? Which gives the angle described by the radius vector per unit time, and it is analogous to speed, which is the distance traveled per unit time. Speed becomes in translation motion, and angular speed in uniform circular motion. Where the radius in translation motion, where is the radius vector in uniform circular motion. Speed in translation motion, whereas angular speed in the uniform circular motion. Again, I will explain what is the angular speed. That is, the angle described by the radius vector per unit time is nothing but angular speed omega. During one complete revolution, the angle described is 2 pi and the time taken is period t. Hence, the angular speed omega, angle upon time. Here, in translation motion, speed is equal to distance upon time. In uniform circular motion, omega is equal to angle upon time. Here 2 pi r upon t, here 2 pi upon t. Therefore, 2 pi r upon t upon r is nothing but v upon r. The unit of omega is the radian per second. Substituting this value of t in this equation, t is equal to 2 pi r upon v. Substituting this equation, we get v upon r, that is unit of omega in radians per second. This one is the uniform circular motion. Say here theta is equal to omega t, where r is the radius vector. Then expression for the centripetal acceleration, which is in last PPT in slide we saying that the centripetal force which is the directed towards the center of circle, and that acceleration is called as the centripetal acceleration, and that force is called as the centripetal force. Now in this slide we can we can see the expression for the centripetal acceleration. Now see, a particle performing uniform circular motion in anticlockwise sense along a circle of radius r with the angular speed z and period t. Let us choose the coordinates such as this motion is in the xy plane, having the center at origin O. See in this picture. Now let the particle be P0 on positive x-axis. See P0 with the positive x-axis. Then at a given instant t, the radius vector P makes an angle t with the x-axis. See an angle theta where is equal to omega t, r is equal to radius vector. Theta is equal to omega t, and so d theta upon dt is nothing but omega. XY components and the radius vector r will be the r cos theta along x-axis, r sin theta along y-axis. We can substitute this equation with resolvation of two vectors. Vector r is equal to r cos theta into r plus r sin theta into j. Resolvations of vector. In last mathematical methods, we see that the resolvations of vectors, therefore the resultant vector r. See here, this one is the resultant vector r. Along the x-axis r cos theta, along the y-axis r sin theta, and where r is the resultant vector. Now vector r is equal to r cos theta into r plus r sin theta into j. Substituting the value of theta in this equation, where theta is equal to omega t. Substitute this value in equation, we get r cos omega t into I plus r sin omega t into j. Time derivation for the position vector r gives, see, the instantaneous velocity v and time derivative of velocity v gives the acceleration a. The magnitude of r and omega are constant. Therefore, v is equal to dr upon dt. Substituting this value, we get r omega minus sin omega t into I plus cos omega t into j. Therefore, acceleration is nothing but change in velocity upon time. Therefore, dv upon dt, but v is nothing but r omega. V is nothing but r omega. So, substituting this value, we get this equation. Here, minus sign shows that the acceleration is opposite to that of r. With the r ची value आपण substitute केली, r omega is equal to minus omega cos omega t into I, where and minus omega into sin omega t into j. Applying the mathematical rules, formulas, we can write here the magnitude of acceleration is a is equal to omega square r, where v square omega is nothing but v square upon r is equal to omega v. And this is the centripetal acceleration. The force providing this acceleration should also be along the same direction. Hence, centripetal is nothing but force is equal to mass into acceleration. Centripetal acceleration is there. Therefore, minus, substituting this value omega into r, where minus sign shows that the acceleration is opposite to that of r. Here, minus sign shows that the acceleration is opposite to that of radius vector r. The magnitude of f is nothing but m omega square r. Substituting this value, mv square upon r is equal to m omega into v. Next point, conical pendulum. Now see in this equation, conical pendulum, f cos theta, where two components are balancing this point in vertical direction, in downward direction. In vertical component, f cos theta, in downward direction, mass into gravity, and f sin theta is the in horizontal position, where h is the height, where l cos theta h upon cos theta is equal to h upon l. Therefore, h is equal to l cos theta. See, first of all, what is meaning of conical pendulum? A small block of mass m is rotated in a horizontal circle with the help of string of length L connected to the m. The other end of string is fixed to a point O vertically above the center of the circle so that the string is always inclined with the vertical at an angle theta. This arrangement is called as conical pendulum. Again, I will explain. Suppose a small block of mass m is rotated in a horizontal circle. See, there is a small block with the help of string. This one is the string. Length L is connected to m. This one is the m. The other end of string is fixed at point O vertically above the center of circle so that the string is always inclined vertical at an angle theta. See, this one is the theta. Again, strings is vertically above the center of circle, and this arrangement is known as conical pendulum. See, in a simple pendulum of mass m is suspended by a string of length L and moves along an arc of vertical circle. If the mass instead revolves in a horizontal circle and the string which makes a constant angle with the vertical describe a cone and whose vertex is a fixed point O, then the mass string system is called as the conical pendulum. Suppose the constant angle with the vertical describes a cone and whose vertex is fixed at the point O. This mass string system is called as conical pendulum. In the absence of friction, the system will continue indefinitely once started. As shown in figure, the force acting on bob of mass m, the conical pendulums are. आता यामध्ये दोन here in this equation, in this diagram. First one is the gravitational force mg acting vertically downward. See, this one is the mg vertically downward. Then force due to tension T you are acting along the string is directed upward towards the support. There are only two forces acting on the body or acting on bob. For the bob undergoes horizontal circular motion, that is radius r, the resultant force must be centripetal, that is towards the center of the circle, and other force, vertical gravitation force, must be balanced. Now see, in this equation, there are two components, T cos theta, T sin theta. Vertical components, downward components can be balanced by mass into gravity. Vertical components, T cos theta, tension in the string. T sin theta, where r is the radius vector, L is the length of the string, and theta is make an angle with the point vertical point O. Thus, we resolve the tension T into mutually perpendicular components. Let theta be the angle made by the string with the vertical at any position. See, here T is the tension T in the string can be resolved into two components, T sin theta and T cos theta, where the component T cos theta acting vertically upward. See, T cos theta acting in vertically upward direction, and the inclination should be such that T cos theta is equal to mg, which is the balance by mg, so that there is a no net vertical force which is can be balanced. T cos theta, the force can be balanced, mass into gravity, that is mg. The resultant force on the bob is then T sin theta, which is the radial or centripetal or directed towards the center O, that is T sin theta is equal to mv square upon r is equal to mr omega square, where T sin theta is the centripetal force, that is the towards the center of the circle. T cos theta can be balanced by mg, but T sin theta is nothing but the radial or the centripetal or directed towards the center, that is O dash here, and T sin theta is equal to mv square upon r, that is v square, r is nothing but omega square, therefore mr omega square, v is equal to r omega. Substituting this value, we get T sin theta is equal to mr omega square. Now see, tan theta. tan theta, we can see that tan theta is equal to mv square upon r upon mg. So m get cancelled, v square upon rg. See here, v square upon rg. That is, since we solve this equation, we get tan theta is equal to v square upon rg. But we note that the v is nothing but speed of the any object is nothing but 2 pi r upon t. Therefore, substituting the value of v in above equation, we get tan theta is equal to 4 pi square r square. V square ची value आपण substitute केली 4 pi square r square upon t square into rg. Now, therefore, t is equal to tension काढायचं आपल्याला. Therefore, t is equal to 2 pi under root r upon g tan theta. Here r square, r get cancelled. Therefore, 4 pi under root becomes outside line 2 pi. इथे फक्त r राहतो, r upon g tan theta. हा t इकडे आला. Solving this equation, we get t is equal to 2 pi under root r upon g tan theta, where t is equal to 2 pi. Now r is equal to nothing but L sin theta. Therefore, substituting r is nothing but L sin theta. Substituting in above equation, we get t is equal to 2 pi under root L sin theta upon g tan theta. Above now, t is equal to 2 pi under root L as it is sin theta upon cos theta is nothing but tan theta. मग ते value से substitute केल्यानंतर this equation becomes L cos theta upon g. But nothing but L cos theta is nothing but h. Therefore, t is equal to 2 pi under root h upon g. See, in here we can say that cos theta in the conical pendulum, f cos theta, f sin theta, which is the object, can be balanced, can be resolved into two components. This force, this tension can be resolved into two components, f cos theta, f sin theta. F cos theta can be balanced by the weight mg, but m sin theta is nothing but the centripetal force or centripetal acceleration is nothing but mv square upon r, that is m r omega square. But here cos theta, this is the theta, is nothing but h upon L. Therefore, h is equal to L cos theta. See, substituting here, how can h is equal to L cos theta? We have already seen. Therefore, t is equal to 2 pi under root L h upon g, where h is the length of the pendulum and h is the vertical distance of the horizontal circle from the fixed point O. This is the expression for the conical pendulum. I think we already understand this one. I can again explain. See, where the tension T can be resolved into two components, T cos theta, T sin theta. T cos theta can be balanced by the weight mg, but T sin theta is nothing but the radial or centripetal or directed towards the center, that is m r omega square, that is the centripetal force. Therefore, tan theta is nothing but mv square upon r upon mg. Substituting this value, v is equal to 2 pi r upon t in above equation, we get tan theta is equal to 4 pi square r square upon t square into rg. Now, solving this equation, we get t is equal to 2 pi under h upon g, where h is nothing but L cos theta, where L is the length of the pendulum and S is the vertical distance of the horizontal circle from the fixed point O. Now, in this way, we explain this scene. First of all, maximum height. What is the definition of maximum height? Then this equation h is equal to u square y upon 2g. Then we see the equation of motion of projectile, that is in the form of parabola, that is y is equal to x plus bx square, which is the equation of parabola. And this is the equation is nothing but y is equal to tan theta into x minus half g u square cos square theta into x square. This is the equation of trajectory of a projectile. Then uniform circular motion, definition of uniform circular motion, which is the constant speed along the circular path which is only happens possible if its velocity is always tangential. This one is the tangential to the circular path without change in its magnitude. Next one, explanation for the uniform circular motion. There are the two types of forces, centripetal force or centrifugal force. Centripetal force is the force which is directed towards the center of the circle, and centrifugal force which is directed from the away from the center of the circle. That force is called as the centrifugal force, and for the uniform circular motion it is necessary for the centripetal force. Then period, definitions of period, radius vector and angular speed. Radius period is the time taken by the object to complete one resolvation is called as the period. Then radius vector and angular speed is nothing but angle described by the radius vector per unit time is nothing but the angular speed. Then uniform circular motion, expression for the uniform circular motion, we get A is equal to omega square r is equal to v square upon r into omega v. Then conical pendulum, and definition of conical pendulum, a small block of mass m is rotated in a horizontal circle with the help of a string length L connected to the mass m, and other end of the string is fixed to a point O vertically above the center of the circle, so that the string is always inclined with the vertical at an angle theta. This arrangement is called as the conical pendulum. Then explanation for the conical pendulum. Then this is the equation of the conical pendulum, that is P is equal to 2 pi up into h upon g, where h is equal to L cos theta. Okay. Now in this way the motion in plane, the chapter is finished.